The focus of our discussion today will be back in the coordinate plane, so you're going to want to have your calculator handy because we'll be using slope, midpoint, and distance formulas again. Today our discussion will focus around right triangles and side lengths. Now, just like a couple days ago when you were introduced to the whole idea of coordinate proof, our steps today are going to be exactly the same. Draw and label the graph, state the formula or formulas that you'll use, show all of your work, and lastly, have a concluding sentence that states what you've proven and how come it has to be true. All right, so let's go ahead and jump right in. In number 1, we're given triangle ABC with those coordinates. They want us to prove that this triangle is an isosceles right triangle. So you should know from our discussion the other day that an isosceles triangle means we have to show that it has two congruent sides, or in other words, two sides of equal length. So we know we're going to have to use distance formula. The part that's new today is this part about being a right triangle, and I think I'm going to go more into depth with that as we proceed through the problem. But to get things started, I'm going to go ahead and plot that triangle. So there's point A. There's point B. And lastly, point C. So he's the star of the show. He's the fellow that we're going to work with. And just like the other day, if I want to prove that I have a triangle whose sides, or two of whom sides, are congruent, I'm going to use the distance formula to do that. So first thing I'm going to do is write down that distance formula. And then I'm going to start substituting some values in. So first thing I'm going to do is find the distance between points A and B. And this is where you'll want to go grab your calculator and punch the numbers in at home as I'm punching them in here on my calculator, so that you can get the practice that you need to be successful with distance formula. So my calculator is telling me that what's underneath the square root sign is 50. 50 is not a perfect square, but it does have a factor that is. 25 will go in there 2 times. So in simplest radical form, the length of line segment AB is going to be 5 square roots of 2. All right, next one I'm going to go on and find is the length of side BC, or in other words, the distance between points B and C. And this one too, you really want to take advantage of at home of that opportunity to practice the distance formula. So in this question, underneath the radical goes 25. 25 is a perfect square, and its square root is 5. So distance between points B and C, or in other words, the length of line segment BC, 5 units long. And then the third one that I want to go find is distance between points A and C. And this one too, I'm going to go ahead and plug this into my calculator. Excellent. I was starting to get a little bit worried there because I knew if they're asking me to prove that this triangle is isosceles, that two of these lengths should come out the same. And indeed, when all is said and done, two of these sides do have equal measure. All right, so the first part of that, they asked us to prove that the triangle was isosceles. I can go ahead now and state with confidence that triangle ABC is isosceles, and that's what I've proven. And now I need to state the reason why. Wow. Let's go back and spell that correctly. Since it has two congruent sides. And now the last part of that, in order to prove that it's a right triangle, I could go through and say, well, I know a right triangle is any triangle that contains a right angle. If I could use slopes, in particular negative reciprocal slopes, to show that those two lines are two of the line segments that form the sides of the triangle are perpendicular, then that would make a right angle, causing the triangle to be a right triangle. However, I'm going to be a little clever and sneaky about this because I already have the lengths of all three sides. And I also remember from middle school that anytime a triangle is a right triangle, it's the lengths of its sides will satisfy the Pythagorean theorem. So what I'm going to do here is I'm going to make use of the Pythagorean theorem. And I'm going to go see if the lengths of its three sides satisfy or work in the Pythagorean theorem. Now, the only thing you have to be careful of here is which values you substitute in for A, B, and C. A and B represent the sides or the lengths of the legs. C must be the hypotenuse or the longest side of the triangle. So my hypotenuse here is going to be my 5 square root of 2, and my two legs will be 5 and 5. So I want to see if the length of the first leg, 5 squared, plus the length of the second leg, 5 squared, equals the length of the hypotenuse, 5 square roots of 2. Since I want to square the whole length of the hypotenuse, I'm going to wrap parentheses around all of 5 root 2, and I'm going to square it. This I'm just going to substitute into or plug into my calculator. I'm going to type in 5 squared plus 5 squared and see what that's equal to. So when I evaluate the left side of my the left side of my equation, my calculator tells me that this sum here is 50. I'm going to go do the same thing for the right side. So I want to take 5 square roots of 2. And I want to square that whole expression, so I'm going to make sure the exponent goes outside the parentheses. The right side of that equation is also equal to 50, so therefore the lengths of the sides satisfy the Pythagorean theorem, making this triangle a right triangle. So I'm going to say my concluding statement, triangle ABC is a right triangle. Because the lengths of its sides satisfy the Pythagorean theorem. And again, an alternate way to solve this would have been to use slopes to prove that the lines were perpendicular, thus forming a right triangle or a right angle, and then any triangle that contains a right angle has to be a right triangle. But since I already had the lengths of all three sides of the triangle, it was much more efficient just to substitute into the Pythagorean theorem. All right, at this point, if you have any questions, please jot them down. in the margin so that you'll remember to ask the next time that you come to class. And as always, thank you for the investment of your time in watching the video and learning about coordinate proof.